with a video. Ladies and gentlemen, I would very much like to welcome you to this session on maintenance and rehabilitation. My name is Helene Odelius, and just a few words about myself. I work at Nines, and I'm responsible for technical support and product development in our bitumen business in Nordic, Poland, and the Baltic states. This is the last technical session before the closing session, and I hope you all have had opportunity to make new contacts and absorb new knowledge that you can bring with you to your organizations. I'm confident that this session also will add to that. I would like to ask you to listen carefully and prepare some questions for the presenters. It's always easier if we have a two-way communication, I think. So please think of questions and dare to put them. In order not to lose time, I'll start by introducing our keynote speaker, François Chenon. He is the technical director at Colas France, the member of the large number of working groups. He is the president, for example, of SFERB USIRF, the emulsion producers, and the important part of the International Bitumen Emulsion Federation. Also a board member of IDD RIM, the French Institute for Road, Street and Mobility Infrastructure. And of course the French representative in TC336, Working Group 2 on surface dressing, and a board member at the University of Paris East. He has a broad knowledge in applications in a broad number of areas like hot mix, aggregates, emulsion-based products, cement road-based products as well, and pavement design in Europe and North America, and a number of pavement preservation techniques like chip seals, microsurfacing, and cold-in-place recycling. Please, François, the floor is yours.
Thank you. Yeah, and I work for Colas too, okay, so just to tell you. Okay, good afternoon, good morning, sorry. I'm going to take a picture of the assembly because I think there is a bunch of people missing, and just to send that to your bosses. And first of all, so the idea of the presentation today is just to look at what is pavement preservation and rehabilitation from the contractor's point of view, from the road driver, from the taxpayer. Right now in France, we have a very strong decrease of business linked to constrained budgets. And we found that our customers are not very well advised, and that's something we would like to change a little bit. And we found that the quality of pavement worldwide was decreasing, and pavement preservation was getting more and more important in order to preserve the network of the road thing. Otherwise, we are a taxpayer, And what do we do with the money? Usually the money, even as a car driver, doesn't go really to the road. At the PPRS in 2015, we looked at what was doing worldwide on pavement preservation, on the maintenance of roads, and we found that that was not only done in Europe, that was kind of a worldwide issue in order to look at pavement rehabilitation the right way for everybody in the world. So that was some worldwide issue, and I think the PPRS last year was really a key symposium to show that. Sorry. So road maintenance for a lot of customers became the adjustment of their budget. If they have money, they do something. If they don't have any money, they don't do anything. And right now, they don't do too much. Okay, they are just looking at pavement and they don't do anything about it. So the French industry decided to do some assessment of national routes in France and county routes. And one of our machines broke down on one of the national routes because the potholes was too big. And we found that was kind of an issue, okay. The other thing too, that we look at different, so you can see that on the quick movie there. That means a very, very big issue on the pavement. We all know that kind of curve. The main issue we have right now is to explain to our local community mayors, because we have a lot of them, how they have to deal with it. Usually they are putting the money in the buildings, because that's kind of the old way of doing things, but they're kind of forgetting the roads, which is anyway 80% of the heavy good vehicle traffic and 85% of the passenger traffic. So right now we are doing a lot of education, and you're going to see that on the different presentation. You're going to see technical aspects, and you're going to see training aspect too, because I think even the industry has to train a lot better than they do right now, and I think that's a very key for that. Just to show you that survey is very important, we did same thing with the French industry, a survey of 3 different French departments in order to see what kind of level they were looking at. We look at 400 kilometers, and I think what we would like to give as an advice to the owners is really to know what are their network, how do they behave, what kind of problem do they have, do they are doing joining, are there enough impervious products, what kind of stuff they have to do. And we found that on the 3 departments, one of them we choose a tourism route. That route was very well maintained because there is tourism linked to it. Another department which is more rural, we found that they don't care too much about the road system. And the last one, that was between 2 departments, we found that one was willing to go to the other one, but the other one didn't care to go to the first one, okay? So that's important to have some kind of a link between departments, to have some real nice network in order to show what's going on. What we did right now in France, which is very interesting, I think, for us, we set up an observatory with the French administration, with the French departments, with industry, and all the organisms like CEREMA and IFSTAR, in order to look at the whole network, to have a real assessment of the railway network. Like Jean-François Corté showed the other day, the French network is 1 million kilometers, very important, and really we have to do something for that, mainly on the local roads, because they are kind of the small veins to bring the economy back to the big cities. Roads are not a bad word. Etienne was saying, we don't do a sexy business, but I think that's very important for the economy. We saw with all the flooding occurring in Europe right now that roads are really the key to move things around, because the drones are very nice, but they don't go too far. And I think that's something very important to look at. The roads are really the very strong input for the economy. The other thing too, as in industry, we have to train our people to move to other things than hot mix asphalt. We love hot mix asphalt, okay, we love it. But we found that to adapt to that kind of constrained budget, we have to go to more different techniques with emulsion, with other kind of things in order to adapt to the budget and to the solution of our clients. And we have to better train our crews. One of the paper will talk about that. So I'll see what is important at that session is not to forget that the road network is really the key economy part of the European and the worldwide thing. And the other thing, like I said too, we have to explain to our customers, the ones who are not very well advised, that we need to know they need to know their network, This is public domain. That's part of our taxes. So I think they should have to take a look at it like they do a lot of other things too. And I don't want to see the 50 shades of gray on the pavements anymore, okay? Thank you very much.
Thank you very much, François Chenon. I think we should immediately move to our next speaker for this session, Alexandra Destrade, will give us a presentation on a field study to evaluate different pre-normative interlayer adhesion tests. Alexandra Destrade is a doctor of chemistry and has been working at BRRC for 8 years, the Belgian Road Research Center, as a staff member of the Performance Characteristics and Design Unit within the Asphalt Pavement Bituminous Application and Chemistry Division. Her field of expertise range from tack coats and interlayer adhesion testing to colored asphalt mixtures and color measurements. Within those fields, she is responsible for conducting research projects and providing technical guidance in response to the needs of the sector. Besides her expertise in road technology, she has a keen interest in nanotechnologies and science, as her thesis presented a synthesis on carbon nanotubes, and her postdoctoral thesis dealt with the creation of polypyrrole nanotubes for the creation of biological nanosensors. Alexandra, the floor is yours.
Thank you for the introduction. Hello, everybody. Let's start with the context of my presentation. As everybody knows, for the durability of a road pavement, an effective and durable bond between the various constituent layers is an absolute prerequisite. To ensure the adhesion between successive pavement layers, cationic bitumen emulsions are the most frequently used type of tack coats in Belgium. As you know, several tests are currently available to evaluate the bonding performance between layers based on different loading modes, by example, shear, tensile, and torque. In this context, the European Standardization Committee, CENTC 227, is working on a pre-standard for the determination of interlayer bond strengths, where three main normative test methods are considered: the shear bond test, or SBT, the tensile adhesion test, or TAT, and the torque bond test, or TBT. Further, 4 test methods are described in informative annexes: 3 shear bond tests, and a tensile test making use of the layer adhesion measuring instrument, LAMI for France. Now I would like to focus on the content of the paper. Firstly, it gives an overview and a comparison of 3 pre-normative tests: SBT, TAT, and LAMI. And secondly, it discusses the results of a study in the laboratory and on site in which the 3 tests were used. Concerning the interlayer bonding tests, the principle and the main characteristic of the 3 tests are summarized and compared in the following 2 slides. In this table, you can see that the SBT and the TET can only be carried out in laboratory. On the other hand, the LAMI is carried out on-site according to the pre-standard. For the SBT, it assesses the resistance to horizontal shear stresses in the interlayer bit of 2 road construction layers, and this test is strength controlled. For the TAT and the LAMI, they assess the tensile bond strengths between 2 road construction layers, and these tests are stress controlled. According to the pre-standard, the loading rate for the SBT is 50 mm per minute. For the TET, it's 200 Newton per second, and for the LAMI, it's 240. Concerning the test temperature, for the SBT, it's 20 Celsius degree. For the TET3, temperatures are recommended according to the pre-standard, -10, 0, or +10. And for the LAMI, it's an on-site test, then it's the temperature of the field. For the SBT, the specimens shall be cores of 150 mm of 100 mm. For the TAT, the cores shall be a diameter of 150 mm. And for the LAMI, it's a 100 diameter groove, which is cut through the upper layer down into the bottom layer. Concerning the specifications and the recommendations for the SBT, as you can see on this table, Germany and Switzerland specify minimum average shear strengths in function of the tested interface between a surface or a binder course and between a binder and the base course. But these values are currently criticized, and some authors made recommendations for higher limits, which are based on their experience and on their research. For the TAT, very few countries specify tensile bond strengths, but Austria specifies a minimum average tensile strength at 0 degree, depending on the type of tag code, unmodified or polymer modified. For the LAMI, Quebec specifies a minimum tensile strength value at 10 degree, depending on the surface layer thickness, as you can see in this table. Now I would like to continue with the experimental setup of this field study, but due to time restrictions, the different experimental setup conditions are summarized in a little table. For the SBT and TAT sites, it's a newly constructed roof pavement and consisting of 4 test sections. For the LAMI study, it's a 12 years old pavement divided in 4 test zones. The objectives of these test sites are mainly to validate the specifications and the recommendations, but also to investigate for the SBT and the TAT field sites the impact of tag code type, the nature of the preparation of the underlayer. But as I said before, due to time restriction, I will only present some of the results concerning the SBT and the LAMI. Let's start with the SBT results. It's important to note that the test sections, the 4 test sections, were carried out under good conditions. If you look at this figure, you have the mean shear bond strength in function of the 4 test sections, and you can see that for the 4 test section, the mean shear bond strengths reach comfortably the national specification of 0.85 megapascal, and even satisfy the more severe national recommendation of 1.41 megapascal. These results illustrate clearly the consequences on performance of a proper installation on site. A good tag code, a good rate. Let's continue now with the results for the LAMI, the layer adhesion measuring instrument, and more particularly the test procedure. As you can see on this slide, there is many preliminary steps which are necessary before the LAMI can be used. First, the coring process, the subsequent cleaning of the cut groove, the insertion of the adhesive-free gripper system, the connection to the LAMI. And you can see on the last figure that if the specimen fails, it is visually inspected to determine the mode of failure. In this case, it's a cohesion failure in the upper layer. As you can see on this slide, all the on-site bond strength values for the 4 test zones largely exceed the current Quebec requirement of 0.20 megapascal. To summarize the main points of my paper and my presentation, it must be remembered that first, SBT is a good laboratory test method to investigate the interlayer bond strengths in shear mode. The TAT tensile adhesion test is also a laboratory test method, but to investigate in tensile mode the interlayer tensile strengths or the internal cohesion of the layers. For the LAMI, this equipment seems a relatively simple, fast, and automated test for in-situ assessment of the tensile bond strengths, but its main disadvantages are the time-consuming coring and the cleaning and repairing processes. That's why more field tests are needed first to validate the recommendations for minimum in-situ tensile strength and to determine the precision of this equipment. Last but not least, when the tag codes are applied under good conditions, we can see that the strengths reach recommendations and specifications for the three tests. But German recommendations seem very strict. That's why BRC recommends for minimum shear strengths for SBT, a value of 1.3 megapascal for a new surface, new binder cross interface, and a value of 1.1 megapascal for new binder base cross interface. Thank you for your attention.
Thank you very much, Alexandra. Okay, we will then go to our next presenter, Joralf Aurstad from the Norwegian Public Road Administration in Trondheim in Norway. Joralf will give us a presentation on the influence of asphalt workmanship on pavement service life, which is a very important subject. Joralf is a senior principal engineer at Norwegian Public Roads Administration in Trondheim, as I said. Before joining NPRA in 2005, he was 20 years at SINTEF, the research institute working with pavement research. This means that he has more than 30 years experience with road technology, main topics being design and maintenance of roads and airfields, asphalt pavement. He is also very active in education, a frequent teacher on universities, university colleges, and other courses and seminars within these topics. Recently also editor and main author on 2 new Norwegian textbooks on road technology and road maintenance operations. Joralf, the floor is yours.
Thank you very much, Mr. Chairman. What I will present to you here today, ladies and gentlemen, is some of the output that has come from a research and development program in Norway called Durable Roads. This 5-year program has been conducted by the Norwegian Public Roads Administration. You will find more info about this program in the paper. Situated in the upper left corner of Europe, facing the cold Arctic oceans, the warm streams from Mexico, and the western winds, Norway has a rapidly changing climate. And it is fair to say that these climatic conditions give Norwegian road and pavement engineers a lot of exciting challenges. One of our main problems is that premature pavement failures and distresses occur too often, as shown on this figure. Focus on cost and completion time often leads to low quality work and improper use of materials. And our unfavorable climatic conditions will soon change these pavement weaknesses into pavement distresses. If these early distresses could be avoided, so we can eliminate the bump to the left on the figure, the overall payment life might be substantially increased. Some typical distresses representative for these early failures can be seen here on this slide. Even though it should be obvious to be cautious about, our payments often underperform due to basic things like lack of bonding to a layer underneath and open joints, both longitudinal and transverse. So it doesn't help that the asphalt mix is superior if the execution of the works and our own control procedures is the opposite. You all know very well that there is a large number of test methods available nowadays for material characterization, mix design, and quality control. Most of our asphalt production facilities are also very modern. So, the quality of the asphalt that is loaded on the trucks on the plant is most often okay. But something is happening on the last lap, from the asphalt plant to the finished and compacted pavement on site. Then the question arises, what or who actually decides on the final pavement quality? We have found that there is a need to focus on these guys. Representing both the contractor workers and the professionals in our own road owner organization. And two keywords in this perspective is competence and motivation. Competence and motivation are closely related. We are convinced that the first one leads to the other. And our objective is now to put development of competence and expertise into a system where people in different positions can find courses suitable for his or her position. As described in the paper, our measures can be split in technological improvements and actions more related to competence and expertise building. I must stress that we are still in an early stage in the implementation process, but we already have observed positive effects on the road. Here you can see some of the technical topics we have worked with. I will not go into details here. You can find more about this in the paper and in the reference documents. But we already see, for instance, that more focus and tougher requirements on the execution of joints clearly leads to progress. And we also have great expectations to a new homogeneity mapping module in our laser-based road monitoring system. You will find more examples in the paper. We have developed an easy-to-read best practice guide for asphalt works. This document has been very welcome both to the contractors and to the road administrations. And even though 1/3 of our asphalt mixes go by boat in Norway, guidelines for boat transport have actually been missing until now. But during the Durable Roads program, we have also come up with an easy-to-read print on that matter, specially addressed to boat transport workers. And bringing people together, especially practitioners, can give many valuable effects, as listed on this slide. And as I said, we are now in progress with defining different types of training courses for different jobs and professions, and putting this into system. Here we see our blue line again, representing the present situation. We really hope that our focus on the construction stage now will reduce the number of road sections with early failures and increase the overall payment service life, as illustrated with the green line on the slide. And only a few years in increased service life may add up to substantial figures regarding cost savings over time. In our program, we have tried to come up with an objective estimate on possible future payback. This is based on best practices for determining values of research results. Actually, this is a quite new approach for the Norwegian Road Administration's research and development programs. Norway is not that a big country, but from our perspective, we clearly see that considerable savings are possible. More details about these calculations can be found in the paper for those of you who are interested. To conclude, we are convinced that we can obtain a very good payback when investing in quality, good workmanship and competence building within the road construction and asphalt area. Our Norwegian asphalt roads, good or bad, ends here. You are all welcome to take a visit. Thank you for your attention.
Thank you very much for that interesting presentation. Now we have about 10 minutes for questions for the first three speakers. So if you have any questions, please dare to come forward, or any comments or reflections upon what we've just heard. Please.
I have a question.
Okay, excellent. Thank you.
The system in Norway, do you have like certification of the competence or just training?
We have a system for certification on operation and maintenance, especially winter operation. And we are in progress. There has been a discussion whether this also could be transferred over to summer activities like maintenance, pay works. And we are about to this summer, if I'm not wrong, I think this season is the first year that we will require some official skills certificates from those contractors who actually are doing the work. But we are not completely finished that discussion yet.
Any other questions from the audience or the podium? I can wait. Okay.
Go to the mic.
Perfect. Could you please step up to the microphone? That would be great. Thank you.
Good morning. I have a question for Alexandra.
Could you please present yourself and where you come from? Thank you.
I'm from Ipstar, France. I have a question for Alexandra. Good presentation. Thank you. Regarding that, as you know, the bonding, the interlayer, the condition that's bonding depends of the seasons between the winter and the summer. And I am not agree with you when you say that the German specification is very strict, because we haven't informations about the behavior of the interlayer with the season. Logically, we need to fix the minimum regarding the condition of interlayer with the season. What do you think about this condition of minimum and the behavior of interlayer with season?
According to our experience and the old field studies, we think that the recommendations from Germany are too strict. According to our experience, it's sometimes too difficult to achieve this recommendation, and the field is really okay. It's then for us, it's too dangerous to specify this limit, this minimum average strength of 1.41 for the interface between the upper layer and the under layer, according to the precision also of the shear bond strength. Then our recommendations are BRC is the value I have done on my slide. This is our experience based on many, many field studies.
Thank you. Another question up there, please.
Christian Angst from Switzerland. It's not a question, it's a comment. We introduced in Switzerland the same values as in Germany. And when we did that some years ago, we had some problems with results. But in the meantime, we think about to rise them up because there is absolutely no problem to reach them. So I do not agree if you say that the German values are too strict. We made the experience in Switzerland that if you introduce that, you will see that the contractor will react and you have better results. That's a comment.
Okay, thank you for that. Super.
My name is Wenche Hovien. I am from the Public Road Administration in Norway. I have a question regarding shear bond test. Have you done any studies testing shear bond strength at different textures on the old pavement?
Yes, on the other field studies we have tested different microtexture of milled surfaces, and sometimes it depends on the field conditions, but we have seen that with a higher microtexture we have what we can call interlocking between the two layers, and it gives higher shear strength, but it depends on the field conditions, the type of tech code, the rate of spreading, but sometimes it's better, sometimes it's worse. It's not already the same according to the various conditions.
Okay, I ask because we have done some studies in Norway, and we see a very large effect on shear bond test. If the pavement is rough, the shear bond test gets very high, and when we add tack coat more and more, it will be less and less. The strength will be less. So I wonder what kind of tack coat are you using? What kind of penetration on the bitumen?
Yes, we are using cationic bitumen emulsions, and with a binder content of 60%, and we are using a soft bitumen emulsion, and sometimes what we call anti-adhesive cationic emulsion with harder bitumens. We use both in Belgium.
And what is the typical penetration grade? Because in Norway we use...
For the soft bitumen it's 160 to 220, and for the anti-adhesive cationic emulsion it depends, it can be 50, 70 or 35, 50.
Okay, thank you.
Thank you. Anybody else that has a question? Okay, I would like to put a question to François Chenon regarding the lobbying. Yes, I think there has been a long history of trying to get road owners to understand the importance of maintenance. Do you have any specific ideas on how to be more efficient in that, or how to present that?
Yeah, we can have a radical ideas is to take care of all the network by ourselves, but that won't work too good. No, what we do right now, we are with the French industry emulsion producers, we are doing some regional tours to go to city owners in order to tell them you have a network, the cost of your the importance of the budget of the network with the maintenance, and we try to start doing that. We think that the observatory, which was just set up at the end of April, I think, it's a good idea too, because it's a way to, we don't know if it will be very transparent, but I think the idea is to show that different owners, they are looking at that network in order to see the needs, in order to have a certain level. And the last thing, that in the east of France, they have a program which is G-Pure, which is kind of difficult to translate right just like now, G-E-P-U-R, and that's a way to bring together 3 or 4 French departments from the east of France, cities, in order for them to do the assessment of their actual network, the needs to obtain certain level, and I think that it's a good idea. That I think what I saw, we did a quick trip to the US last year with some French guys, and what we found in Virginia, that the state is very transparent. That means they give information to the citizen with no secrets. I mean, we spend that money, you give us that money through taxes, this is the level of our roads, and I think that's something we think the owners should do when the times are very difficult. I think that's important to show to the citizen that they do everything they can in order to raise the level of the network, but they can't because of the money. And I think that transparency from the owner to the citizen, we talk a lot about social media and things like that. And I think that's a big part of that too. I think that we have to be very transparent with the one who gave the money or are still giving the money through taxes, to upgrade the network. So I think that's very, very important for me. So that different things, local cities through the industry, and maybe with that observatory which was just set up to have a global view of what needed and what's going on. And that east of France studies is very interesting too, because that's kind of, we saw the impact of that right now. Okay? So that's very important. And in France, just to finish, we had 2 big accidents on the network. One bus burned, it wasn't very nice. But that's the first time we saw that the owners very quickly told the media that the road has been maintained the last 3 years ago, 4 years ago. That was the first time in a big bus accident that the owner of the pavement, the owner of the road, decided to tell the people that they did exactly what was needed to do. Okay, so I think that's it's a way to look at things a bit different than they were before. Before that was an accident, that's it. Now it seems that responsibilities are getting better, and because the network is getting bad too. So that's you can see that very easy. And on the social media, I'm very long. Okay, sorry. On the social media, there is an association which is 40 million of drivers, and they set up a website. So in English, it's j'ai mal à ma road, so it's kind of difficult. I mean, my road is in bad shape.com, something like that. And they received the first 3 weeks when they opened that network, 30,000 slides of trouble in France on the different network. So I think that's why that social media aspect is quite important, because it's a way to go directly from the citizen to the political people. And globally, all the technical people who are working for the administration are aware of that. Okay, so I think that's important that the politicians will be aware of that kind of thing. So you can see that social media, I think, is getting more and more important in our business. Thank you.
Thank you very much. Anybody else that has come up with a question?
Good morning to you. I'm Russell Clayton from GHD in Australia. This discussion of adhesion of interlayers is something that I've been very interested in for quite a while. And I think NCAT, the National Centre for Asphalt Technology in the UK, did quite a lot, in America, did quite a lot of work at looking at bond strength, and it's certainly worth looking at what they did. They also built a trial pavement, which they trafficked, and from memory, what became very apparent is the emulsion tack coats were the least successful in terms of performance, and what they found is there was debonding in the upper layers. Just recently, we've visited iStar, and they've also mentioned high temperature debonding on some of their upper layers. This leads me to the question of the test that you're carrying out is at 20 degrees Celsius. In Australia, for instance, our road surface temperatures go up to 70 degrees. And if you're using bitumens that have a softening point of maybe 45 degrees, are we actually testing the right thing? Perhaps we should be considering polymer modified binders as the tack coat so that we can resist or improve the adhesion between the layers.
Thank you for this comment. Just for information, we are using just one temperature according to the pre-standards. And for the polymer modified tack coat, we are using this type of tack coat in Belgium. But sometimes it could not be demonstrated that one type of tack coat performs better than another in comparison of an anti-adhesive or polymer modified tack coat, because the field of conditions are great, and it's really there are a lot of parameters taking into account to have a good bonding between the layers, not only the tack coat. But in Belgium, in our field study, it's not always the case that polymer modified cationic emulsion performs better than another.
I have a question.
Okay, just to add as a contractor, okay, lab results are very interesting, but we don't put the tack coat in labs, okay, we put tack coats on the fields, and the fields conditions are very complicated to maintain or to look at. And we had some issues once in a while, with tack coat, because of the job is very short, night job, you have to clean, you have to wash, you have to wait for the thing, and tack coat on concrete sometimes too. I love concrete, but I mean, it's just to tell you that it's very, very difficult for me to have the link between the laboratory and the real life. And in France, Ferrat, they are using a screwdriver to be sure that the course is okay on site, okay? So I don't know about the calibration of the screwdriver. But it's just to tell you that for us as a contractor, because obviously sometimes you have penalties behind that thing, it's very, very difficult to have that link between a lab condition, which is usually nice, and a job condition, which can be a night work, rain, things, so that's something very, very difficult. And we think that we need some tests who are more on the maybe radar, stuff like that, to take a look at what's going on the field, because those lab results are very difficult to cope with the job site.
Maybe I missed it, but how do you control the temperature 40 millimeters in a field test at 20 degrees C?
For the LAMI? For which test?
For the field test, yeah.
For the field test. The LAMI is only an on-site test. For the SBT and the TAT, the tests are performed in the laboratory on a controlled chamber.
So for the LAMI test, there is no set temperature?
For a LAMI test, you can perform it in laboratory at 20 degrees, but on field you are using the field temperature. But there is what we call a correction factor, and you can correct your resistance at 20 degrees. It's written in the pre-standard.
Okay, thank you. I have a short question to you, Ralph, as well. You talk a lot about competence improvement. Have you identified a few very important areas where competence needs to be raised? And could you mention a couple that are really important for the outcome?
Yes, to balance between the contractors and ourselves, so to speak, I can take one example from each. For our older administration, it has been very important to gather our controllers that are on the field, controlling the work, because often you see in a widespread country like Norway that different procedures are used in different parts of the country, so the contractors may meet different requirements and different, more or less, philosophies around. So one important thing has been to gather and try to harmonize and our own procedures with training courses, typical 2 days, coming together and going through the coming season, going through our equipment, do the calibrations and so on. That has been very useful. Quite simple, but very, very useful. And I was pleased to say on the poster session that another thing that we have been discussing, not implementing yet in Norway, but there was a poster here dealing with directly on that topic. That is the competence of the guy or the man or the lady sitting on the roller to do proper compaction. Because we see that this is perhaps the key link in getting a good result out on the road. So we are in progress also defining some kind of special courses or requirements on that kind of works. Yes.
Thank you very much. I think it's time to proceed to the next speaker, Peter E. Sabali. Peter is a professor of civil engineering and director of the Western Regional Superpave Center at the University of Nevada in Reno. He is a registered professional engineer in the state of Nevada and earned his Bachelor of Science in Chemical Engineering and the Master of Science in Chemical Engineering from the State University of New York at Buffalo, and his PhD from Arizona State University, specializing in pavement materials and engineering. He is currently working on several research projects in the development of new engineered materials to enhance the durability and sustainability of asphalt pavements, and the incorporation of these materials into design methods and specifications for maintenance, rehabilitation, and constructions of pavements. Peter, the floor is yours.
I've been called a lot of stuff, but not chemical engineer. I am a civil engineer.
I am very, very sorry about that.
That's all right. Well, good afternoon or good morning. I think we're still before noon. My presentation is about preventive maintenance of asphalt pavements. We spend millions and millions of euros and dollars building the pavements, and then some of us do not pay attention to preventive maintenance. We need to maintain pavements in order to get the full benefits of their service life. In this research study, and actually more practical study, we looked at slurry seals. And in this slide, you can see the slurry seal, freshly applied slurry seals and fully cured slurry seal. Sometimes we refer to it as the microsurfacing. So if we use polymer modified emulsion and high quality aggregates, then we call it microsurfacing. If it is normal emulsion and normal aggregates, then we call it slurry seal. So the idea is to not only build those preventive maintenance, but make sure they perform all over their service life. In our part of the state, in Nevada, the slurry seals have to survive very harsh winters. This is temperatures like in the minus 25 degrees C, all the way to the heat of the summer, where you can reach up to 60 degrees C pavement temperatures. In between those extreme temperatures, you got a lot of freeze-thaw cycling, hundreds and hundreds of freeze-thaw cycles in a year. So they have to maintain the roads and also get a good performance out of that. How do we do that? Well, we rely on our pavement management systems. We started building and setting up pavement management systems in the 80s, but we spent a lot of time and a lot of money on fancy equipments and a lot of fancy data collection schemes, which at the end we ran out of money to do data analysis. In this study, we went back to the basis to study and evaluate the data from the pavement management system. If you don't have a system to evaluate your data, your pavement management system is worthless. So my advice to you is don't spend a lot of money on fancy equipment. Just make sure that the data collected is analyzed correctly and you get something out of it. And I'll show you some examples of that. So in this study, we looked at collect the performance data manually, no fancy equipment, anything like that. All the stress data were collected manually for the past 25 years. We looked at some pavements that have no slurry seals at all, and we looked at some pavement that has single slurry seals that were applied at 0, 1, 3, 5, 7, and 9 years after construction. And we looked at another study, followed-up study was sequential slurry seals, where we applied the first slurry seal at certain year and then follow it by another slurry seal. So what did we find out? The first thing you will find out is that if you have a successful pavement management system, then you can build a performance model for your pavements without any maintenance or effective preventive maintenance. And this is the green curve right there. And then if you look at the performance of your preventive maintenance, you should be able to build the performance curves for your slurry seal and the second application of your slurry seals. And you can see we define the performance life is when the level of the pavement condition index goes back to the same level and at which the slurry seal was applied. And this example, the life of the slurry seal is 2 years. The performance life of the slurry seal is 2 years, while in this one is 3 years because it took it 3 years to go back to the same PCI level. So taking that information and combining it also with cost level, with cost information, if you can, again, if you are able to build your performance curves and also combine it with cost analysis, then you have an excellent pavement management system. So if you do the benefit of the pavement, here you go. So if you have the benefits under the performance curves and then you have your cost figures, you can calculate your relative benefit and you can calculate the benefit cost ratio. Your relative benefit is the benefit that you achieve by increasing the performance curve of the pavements through the preventive maintenance and then dividing it by the area under the curve where the pavement would not have received any preventive maintenance. So taking a look at the effective maintenance and the cost-benefit ratio, we looked at brand new pavement, new construction, and also overlaid. And we found out that the best time or the most effective time for new construction to apply effective maintenance is, or preventive maintenance, is at around 3 years old, after the pavement is 3 years old. We looked at the overlays and exactly what we expected was overlays that are more variability, so the effective time is a little more variable than brand new construction. So the first phase of the study concluded that you need to apply the pavement effective or preventive maintenance 3 years after construction. If you are dealing with a new construction, if you're dealing with overlays, you can relax a little bit and apply it 3 to 5 years after construction. There are some of our engineers that believed applying slurry seal immediately after construction will improve the performance of the pavement. Well, we found out that this is waste of money and waste of time. Do not apply slurry seals immediately after construction. Then we moved on to the multiple slurry seals. First slurry seal, this is again the pavement without any application of a preventive maintenance. This is the first slurry seal, and this is the second repeated or sequential slurry seal. And then we looked at the effectiveness again in terms of extension of performance life of the first slurry seal, performance life of the second slurry seal, and the extension in pavement life. And you can see that applying the slurry seal immediately and then waiting 7 years later is not the most effective way, or 9 years later, or even 1 year, you're not getting benefit of that. Where they all peak is if you apply it 3 years and followed by 7 years. For new construction, the same thing. You get the best extension life, the best performance of the both slurry seals if you apply 3 years, first slurry seal, followed by the second slurry seal after 7 years. And then we looked at the cost benefit. Again, if you are equipped to do this kind of analysis through your PMS, you can get your benefit from the multiple sequential slurry seal applications, and then you divide it by the pavement without any preventive maintenance, then you get your relative benefit and your cost-benefit ratio or benefit-cost ratio. Looking at both the relative benefit and the benefit-cost ratio, where do they peak? Again, not at 0, not at 1, 3 years followed by 7 years. This is the best benefit-cost ratio and the best relative benefit-cost ratio, benefit-cost ratio, the highest for overlays, and for new construction, again, 3 years followed by 7 years, 3 years followed by 9 years. So if you really want to maintain your pavement, like most of the speakers indicate, if you want to have an effective pavement over the service life, you should be applying single or multiple slurry seals. We recommend multiple slurry seals because they are very, very cost effective. Again, so in conclusions, both brand new pavement and overlays, you should apply, wait for the first 3 years, then apply anywhere between 3 to 5 years, your first preventive maintenance, and followed by 7 years later, apply the second preventive maintenance, and you get your most cost-benefit ratio and the most effectiveness of your preventive maintenance application. And I thank you. I just want to say that it was the most difficult to have a professor speaks only for 10 minutes, but I did it.
You did it very well, and thank you very much. We will jump to our next speaker right away. It's Peter T. from Rijkswaterstaat, the Ministry of Transport and the Environment in Utrecht in the Netherlands. Peter is the project manager of the Corporate Innovation Program, Advisor Roads and Maintenance. The last 15 years, Peter was responsible for several projects in the field of silent roads, in which the acoustic behavior of porous road surfaces were studied and optimized using large-scale test sections on highways and test tracks like Kloostersande. During a period of 5 years, Peter was also responsible for the project LVO Rejuvenator, in which project life prolonging and preventive techniques were developed and studied in cooperation between contractors, a public body, and research institutes, Delft University and TNO. At the moment, Peter is responsible for the project Ultra Silence Road Surfaces, in which a poroelastic road surface will be developed with at least a noise reduction of 10 decibel to the reference dense asphalt concrete AC Surf 16, and also expected to have a service life of 7 years. Peter, please, the floor is yours.
Thank you, Mr. Chairman. I'd like the committee to thank you for getting the opportunity to present my paper. The subject of my presentation is increasing the life of porous asphalt by preventive maintenance techniques. The following aspects will be covered in my presentation. I will give a short introduction on the use of porous asphalt on the Dutch highway, and we'll give a presentation about the old and new maintenance strategy and how we get the new maintenance strategy by thinking differently. And I will address also the approach of the project, and I will finalize with the environmental aspects such as life cycle assessment and life cycle cost analysis, and I will conclude with the results and the conclusions. Rijkswaterstaat is responsible for the maintenance of the highways in the Netherlands. Almost 87% of the highways in the Netherlands consist of porous asphalt. The use of porous asphalt has a lot of advantages. The major mechanism for reaching the end of life of porous asphalt is raffling. Raffling is the process in which stones are popping out of the surface due to the traffic. The raffling process is mainly caused through aging of the bitumen binder, which becomes brittle and less flexible. In general, the slow ride lane with the heavy traffic has a shorter lifetime. It's about 11 years in the practice. And for the fast lane, the average service life is about 17 years. The standard maintenance strategy in the Netherlands is that after 11 years, the slow lane will be milled, and there will be a new layer applied to this lane. And after 6 years, that is in year 17, major maintenance will be done by inspecting the foundation of the road and placing a new top layer carriageway wide. In order to decrease the maintenance costs, Rijkswaterstaat was looking for a new preventive way to increase the service lifetime of the slow lane to 17 years. An innovative solution was considered by preventive spraying a rejuvenator on the surface of the porous asphalt. And this should result in rejuvenating the aged binder in the mortar bridges and to fill the micro cracks in the mortar and between the mortar and the stone. And this will, of course, improve the adhesion and the cohesion. Also, by spraying the rejuvenator, we also add extra binder to strengthen the bridge between the stone and the mortar. And this will also protect against the aging. We have set up a lot of test sections, and we have done this by a cooperation between the government, the contractors, and also the research institute. And every party has its own role in it. The contractors, they are going to produce and to do the job, and we are just giving some idea about giving the opportunity to build test sections, and TNO and TU Delft will help by doing some research. The objective of the 4 years research program was to increase the service life of the porous asphalt by preventive maintenance. From visual inspection and laser crack measurements, it's known that in general, the raffling on porous asphalt will start approximately 5 years after pavement. And therefore, we have found out and set up the way we have chosen it. We prepared 8 porous asphalt field trials on existing highways, and each surface was 5 years old and had a length of about 4 to 5 kilometers, and those test sections was used to investigate the effect of rejuvenating. The contractors developed and prepared the method and the application method to install the sealing product. The requirement was that the process can be done with a speed of about 6 kilometers in a night shift. Monitoring of the functional properties has been done by application, by looking at the functional properties like the skid resistance, raffling, acoustic behavior, permeability, and the texture, and also fundamental lab research on cores from the field sections. Setting up the test section first start by cleaning the porous asphalt surface with the porous asphalt cleaner. Then each trial was subdivided into treated and non-treated sections. The non-treated sections were approximately 300 meters long, and the treated section had a length of about 1 kilometer. One of the test sections was treated with Modiseal ZX, that is a hot polymer modified binder with a rejuvenator. After spraying, it was finished by a tire roller. Then we have Pentac, this is a cold emulsion. And finally, we have the third party, this is the Modifill ZV. And after spraying, an air jet blower was used to penetrate the surface. During the test period, the following functional aspects has been monitored. The early skid resistance. We know that after spraying, the skid resistance will be less. And you can see that after about 1 week, it reached the previous skid resistance we had before spraying. We also used the laser crack measurements. We used the data from a laser crack machine to look at the exact loss of stones after the spraying. It has been reported that the loss of stones significantly decreased in the rejuvenated sections, while the raffling process is still going on in the non-treated sections. Also, the CPX measurement has been done to look at the acoustic behavior after sealing, and then you can see that there's almost no significant difference. Cores from the field trials were used to investigate the volumetric changes and the chemical properties of the binder and the mechanical properties. Also, we have made samples out of the cores and to look under the microscope. And you can see the penetration of the rejuvenator and filling the cracks in the top layer of the surface. We have also looked at the environment aspect and the cost. The impact of the environment by the standard way of road maintenance by means of milling and innovative way of maintenance by means of rejuvenating the road was studied. And you can see a clear difference, and it can be very favorable to use the new technique. In this table, an overview is given for the objectives of the test conducted and their result. And the most important is the last one. You can see that from the field observation, you can see that by using the laser crack measurement, that you can see that the lifetime extension is at least 4 years old. Monitoring is still underway. I like to come to the results and the conclusions of the project. The 3 rejuvenators are suitable to increase the cost-effectively the service life of porous asphalt with at least 4 years by preventive maintenance. The developed material tests and procedures are suitable to judge the alternative rejuvenators. And finally, the results of the life cycle analysis of the preventive maintenance system can be used for a cost-benefit calculation. I thank you.
Thank you very much. Our last presenter today, before final questions, is Johan Gerber. Johan is affiliated with the University of Stellenbosch in South Africa, where he completed his undergraduate and postgraduate studies, currently working as a contractor for roadmap surfacing within the Robux group, focusing on the construction of chip seals and asphalt overlays in urban and rural areas. He will typically manage the construction teams on site. Okay, welcome.
Thank you very much, ladies and gentlemen. It's really good to be in Prague, and I thank you for this opportunity to present the work that our SEAL team has done in South Africa. South Africa has a total road network stretching about 750,000 kilometers, and a fifth of that is paved. So just to put that in perspective, our paved road network can stretch about 4 times around the earth. 80% of the paved road network is sealed, and therefore our roads agency, SANRAL, asked us to investigate chip seal deterioration in order to check new materials, old materials, and identify adequate maintenance intervals. So if I can move forward. If you ask a contractor how to construct a chip seal, he will say, you need experience and we can do it. If you ask the consultant, he will say, there's definite science in constructing seals. So it's generally accepted in South Africa that seal construction is as much an art as a science, so everybody is now happy. Further, the failure mechanisms remain the same, and the major ones we have in South Africa are stripping, meaning a loss of aggregate or a deterioration of the bond. Secondly, cracking, which can be ideated as cohesive cracking, meaning that the binder itself is deteriorating. And then also we have bleeding, resulting in surface texture loss, and that's due to the aggregate punching into the base, which is called embedment. But without further delay, I'd like to show you a clip of our approach. It's a mechanistic imperial approach consisting of finite element modeling and laboratory material characterization. So enjoy. So the best way in developing a model is to ring fence what you want, and you look at your predecessors, and we can see here that Milne is probably the pioneer in South Africa. He developed a single seal structure, and then follow-up work by Heerman added a base layer to that, and you can see Heerman also extensively did 2D and 3D modeling development for porous concrete asphalt, and these final picture in my lower left corner, some guys in New Zealand, they developed a 3D model based on CT scans. But we didn't really want only one model. We wanted a model generator which is able to model various seal types at various sizes, and we wanted to include various material characteristics for bitumen and the base course, and also include environmental conditions, as well as be able to choose your traffic loads. So we came up with a 2D chip seal model generator, and just to indicate, there's a single seal, that's the one with a single layer of aggregates. It has at the bottom, its cousin, it's a double seal with 2 layers of aggregates, and we zoom into the single seal, and there you can see the individual components consisting of aggregates, bitumen, there's an adhesive zone or an interlayer, and also fog spray keeps the aggregate down, and obviously the base layer. And from these individual components, we will get data that we will later discuss again. Any finite element model needs loading, and we included loading from the stress in motion system developed by the CSIR in South Africa, where they use a set of pins to record the 3D stress signals, and we converted that into a 2D stress signal incorporated into the finite element modeling. Our material analysis was done by my colleague in Pretoria. He did stone column and bitumen column testing to develop a material performance curves, and I myself also looked at a new way in looking at embedment development, where we used an existing field test, the ball penetration test, and we converted it into a repeated ball penetration test by using the materials testing system, which allowed us to use repeated loading. If we look at some of the results, you can see that as the tire contract stress increase, as one would expect, the stress in the seal model increases, and that also leads to a reduction in the number of load repetitions to failure. I'd like to point out something, however, that our design guide states that 40 light vehicles creates the same damage as one heavy vehicle. And from the modeling results, we can see that damage depends on the type of failure mechanism you look at it. If you look at adhesion, which is stripping, we can see that 4 light vehicles equates to 1 heavy vehicle, and similar for cohesion failure, which can be identified with cracking. 2 light vehicles results in the same damage as 1 light vehicle. So that's an interesting result, but I would also like to point out the low number of load repetitions we got for cohesive failure, which is cracking. The reason for that is that we would need to investigate and spend some more time in the performance functions in the laboratory, but it's really promising, and our group is excited about the results as well as the embedment results coming from the repeated ball penetration test. The model indicates results likened to that which is obtained in the field. You can see here the black dots and the red squares are actual field results, and the model, depending on the stiffness of the base, gives similar type of results. And further, we would just like to conclude with the emphasis on maintenance. Finite element modeling is definitely a tool we can use to identify when maintenance is required, but as previously stated, we need more efforts in developing performance functions for the bitumen and the adhesive zone, and the various combinations of materials in South Africa. And further, one of the speakers also mentioned it's really important to get good, reliable field data for validation. And I think that's also a thing that's been lacking to an extent in our industry. And finally, these types of design analysis can be done prior to construction, and therefore also helping with the cost analysis thereof. I would like to thank you all.
Thank you very much for that presentation. We now have only 3 minutes, unfortunately, for your questions. So please and take a microphone pretty fast and ask your questions. Yes, please.
Good morning, Eric Keizer, Total Netherlands. I have a question for Mr. Tay. Can you explain how the rejuvenator is entered into the positions where you want it to have?
Hello. What we have talked with contractors, and we said that we have discussed about the aging process, and we have seen that the aging process is at the top level of the surface in porous asphalt. Dus it doesn't suit to use the rejuvenator in the deeper layer. So each contractor has designed their product in such a way that the product will stick a little bit in the top surface layer, whereas one of the contractors had said, no, I like to have my product a little bit deeper, and to also address the aging and the binding of the product under the stones in the mortar, so it will be blow in a little bit deeper. By experience, the contractors know that they have to use a certain amount of the material and to spray it at a certain speed in order to give the exact amount of seal product on the level in which they like to reach the layer of the surface. And what we have done, that after sealing, we have taken cores out of the test sections, and we have examined all the volumetric properties by using a CT scan and CT nanoscan, and also we have looked using the microscope to look whether the rejuvenator has been arrived to the place where we like them to be there, and it's shown that it has worked that way.
Okay, thank you. I think we have a question here as well.
Yes, my name is Rabura Sabam from Norwegian Public Roads Administration. I have one question to the last presenter. It's very, very interesting work and very good presentation. It's good to see how the tire contact pressure actually affects the deterioration, and how it's different from what we call a track equivalency factor that's usually based on axle load, which is usually used in design, and how it's different from the values you showed us. This analysis is made with respect to chip seals, as you said, but do you think the same values can be applied to normal dense asphalt overlays when it comes to the effect of tire contact pressure and deterioration following that? Another question is whether you have an adhesive failure or a cohesive failure should depend on properties of the binder, I guess. Have you looked at that? How the property of the binder affects which type of failure you get? That's my question.
Can I ask you to give a fairly short answer, because we are unfortunately running out of time, and we're expecting the people from the North Hall to arrive soon.
Your first question, depending on the surface texture, it's obvious smaller contact area will reduce or will lead to higher contact stresses. So you can use the same thinking, but the absolute values will differ. And your second question, we only used a 70-100 penetration grade binder. My colleague is busy with other binders, but the results are not yet available.
Thank you.
Okay, thank you very much. I think there is a comment also from Mr.
I have a question. Reflective cracking is a very major failure in chip seals. I think two-dimensional finite element is not going to do it. You need three-dimensional, right, to go to, or are you going to consider reflective cracking from the existing surface into the chip seal?
Well, we look at the stress and the strains, whether it's from the top or the bottom. And yes, there is definitely reflective cracking if you have a weak base layer. We started off in 2 dimensions. We have the know-how now to do that, and yeah, we're looking into developing the same modeling, but only in 3D with the same approach. And by doing that, you include obviously the 3rd dimension from the tire, the lateral stresses, and it's also possible to build in weak layers at the bottom and see what happens.
Okay, thank you very much. I think we have to leave very soon because the closing session will start immediately after this. So please be seated. I think there are people arriving from the other session in the North Hall right now. And thank you very much to all the presenters, and a big round of applause.